How 12,000 tons of orange peels brought a dead forest back to life. In the mid-1990s, a fleet of trucks rolled off a paved road in northwestern Costa Rica and onto a stretch of burned-out cattle pasture inside the boundary of a national park. Over the course of the delivery, roughly 1,000 of these truckloads dumped their cargo directly onto the bare ground. Not soil, not seedlings, not anything a reforestation project would normally use. Orange peels. Rind, pulp, and pith, the leftover waste from squeezing juice out of oranges, piled onto the degraded land in a layer that in places reached half a meter deep, more than 12,000 metric tons of it in total, spread out with bulldozers across about 3 hectares of dead pasture. Within a year and a half, the peel had rotted down into the ground and vanished. And then, before anyone got the chance to find out what that actually did to the land underneath it, a lawsuit shut the whole project down. A rival company sued. A court agreed with them, and the deal that had made the dumping legal in the first place was terminated. The site was written off. Nobody went back to check on it. For roughly the next 15 years, that patch of land inside a national park sat there, forgotten, while the rest of the world moved on. Then, in 2013, a researcher who happened to be catching up with one of the ecologists behind the original idea remembered the site existed, decided to take a short detour on an unrelated research trip, and went to go see what, if anything, was still there. What he found didn't look anything like a dead pasture. It looked like forest, tall, dense, and green, standing in a spot everyone involved had assumed would still be scrubby grassland at best. This video is the full story of how that happened. The ecologists who proposed dumping industrial food waste in a national park in the first place, the juice company that agreed to it, the lawsuit that killed the project a year in, the 15 forgotten years that followed, and the scientific survey that eventually measured exactly how much of a difference 12,000 tons of orange peel actually made. A difference so large, it's now cited as one of the only documented examples of carbon storage that didn't just avoid a cost, but was funded by one. Picture the two versions of this same patch of land, separated by roughly a decade and a half, and the contrast is almost hard to believe belongs to the same coordinates on a map. Version 1. Flat, sun-baked pasture, a scattering of tough grass, bare, compacted earth showing through in patches, a landscape that had been grazed and degraded for years and showed no particular sign of recovering on its own anytime soon. Version 2. A closed canopy overhead, tree trunks thick enough that a single person couldn't easily wrap their arms around some of them. Leaf litter underfoot instead of bare dirt, the unmistakable layered structure of an actual young forest, not a hopeful patch of scrub. Nobody planted a single one of those trees by hand. Nobody watered them, weeded around them, or tended them through the dry season. The only intervention, ever, was a few months of trucks and orange peels, followed by total silence. To understand why anyone thought this experiment was worth trying in the first place, you have to understand two separate problems that happen to line up perfectly. A forest running out of time, and an industry with millions of tons of waste it needed to get rid of. Start with the forest. The land in question sits inside Costa Rica's Área de Conservación Guanacaste, a conservation area in the northwest of the country, built specifically around one of the most overlooked and most endangered ecosystems on the planet: tropical dry forest. Most people picture a rainforest when they think of the tropics. Dense, permanently wet, dripping with humidity year-round. Tropical dry forest is different. It goes through a real dry season, months at a stretch with little to no rain, and that seasonal rhythm makes it enormously valuable ecologically and, historically, enormously easy to convert into farmland and cattle pasture, because clearing and burning dry season vegetation is simpler than clearing a permanently wet rainforest. That vulnerability shows up starkly in the numbers. Tropical dry forest is considered among the most endangered major tropical ecosystems anywhere on Earth. More endangered, proportionally, than tropical rainforest, despite getting a tiny fraction of the public attention rainforest loss receives. Between 2000 and 2020 alone, more than 71 million hectares of tropical dry forest disappeared globally, an area roughly twice the size of Germany, gone in 20 years. More recent assessments put what remains at only around 32% of the ecosystem's original extent worldwide, down from about 41% as recently as the year 2000, meaning the decline hasn't just continued, it's accelerated. In some regions, less than 8% of the original tropical dry forest cover is left at all. And on top of all of that, less than a third of what remains sits inside any kind of protected area, which means the overwhelming majority of the world's surviving tropical dry forest has no formal protection standing between it and the next wave of clearing. It's worth being specific about why this particular ecosystem gets so little attention relative to how endangered it actually is. Rainforest loss photographs well. Dense, dripping, visually dramatic canopy, easy to contrast against a clear-cut scar. Tropical dry forest, especially during its dry season, already looks brown, sparse, and seasonally leafless, even when it's completely healthy, which means the same ecosystem can be actively thriving or actively dying, and look, to an untrained eye glancing at a photograph, more or less the same either way. That visual ambiguity has real consequences. An ecosystem that's disappearing faster, proportionally, than the rainforest everyone worries about gets a fraction of the conservation funding, media coverage, and public urgency, simply because it doesn't photograph as a crisis the way a burning rainforest does. Costa Rica's Pacific side, including the Guanacaste region specifically, was historically covered in exactly this kind of forest before large-scale cattle ranching moved in over the course of the 20th century and converted huge stretches of it into pasture. The same kind of degraded, grass-covered land that would eventually become the site of this experiment. This is the specific backdrop two ecologists had spent their careers trying to reverse, at a landscape scale, long before the orange peels ever entered the picture. It's worth being clear about what degraded pasture actually means on the ground, because it's easy to underestimate. Decades of cattle grazing doesn't just remove trees. It compacts soil under the weight and hooves of livestock, strips out organic matter through repeated grazing cycles, and hands the competitive advantage to a handful of aggressive, fast-growing pasture grass species that are very good at colonizing disturbed ground and very good at preventing anything else, including tree seedlings, from getting a foothold. Left alone, that kind of land doesn't necessarily drift back toward forest on its own, or at least not quickly. It can sit in a kind of ecological holding pattern for decades, grass winning out over tree seedlings year after year, which is exactly the trap large stretches of the conservation area's land were caught in before any restoration intervention. Now, the other half of the equation. An industry generating an enormous, expensive waste problem, completely unrelated to conservation, that just happened to need somewhere for its byproduct to go. Roughly 40% of all the citrus fruit grown in the world doesn't get sold whole. It gets juiced. And turning citrus into juice generates a genuinely massive amount of leftover material: peel, pulp, and seeds. Globally, citrus processing produces something on the order of 24 million tons of this waste every single year. Peel alone typically makes up around a fifth of an orange's total weight, which means every ton of oranges that goes into a juicing operation leaves behind a substantial mountain of rind that has to go somewhere. That somewhere is not a trivial logistics question. Citrus waste left to rot or dumped carelessly creates a real environmental burden. It places heavy demand on oxygen levels if it degrades in water, and it's expensive to haul away and dispose of properly at industrial scale. For a juice company, that disposal cost is a genuine, recurring line item, year after year, with no obvious upside. Elsewhere in the world, some of that waste gets a second life. Orange peel is a commercial source of pectin, the gelling agent used in a lot of food production, and of a compound called dolimonene, used in various industrial and cleaning products. But even accounting for those uses, a juice operation generates far more peel than any pectin or limonene buyer is going to want, and the rest still has to be disposed of, at cost, indefinitely. Think about what that disposal problem actually looks like from inside a juice company's operations. Every day the plant runs, trucks of fruit come in, juice goes out, and behind the scenes, an entirely separate logistics chain has to deal with a mountain of wet, heavy, quickly rotting rind that nobody wants and nobody's paying for. Landfilling it costs money and uses up landfill capacity for something that isn't actually trash in any useful sense. It's organic material, full of sugars, moisture, and nutrients, just in a form nobody had a cheap use for. From a pure cost accounting perspective, a citrus processor is essentially manufacturing two products every day: juice, which it sells, and a large volume of biodegradable waste, which it has to pay someone else to take away. That second, unwanted product is the exact raw material this entire story turns on. Put those two problems side by side: a forest ecosystem disappearing faster than almost any other tropical habitat on the planet, and an industry drowning in millions of tons of a waste product it has to pay to get rid of, and you have the exact setup for the kind of idea that sounds almost too simple to actually work. What if the thing one side needed to dispose of was exactly what the other side's degraded, nutrient-starved soil actually needed more of? Costa Rica itself sits at an interesting intersection of both halves of this equation. The country is a genuine global conservation success story in some respects. It reversed a national deforestation trend and became known internationally for prioritizing forest protection and ecotourism. It's also a real agricultural exporter, including citrus, which means the same country hosting one of the most ambitious dry forest restoration projects on the planet also hosts commercial juicing operations, generating exactly the kind of waste stream this story turns on. That overlap wasn't a coincidence that had to be engineered from opposite sides of the planet. The company and the conservation area were, quite literally, neighbors. Here's why nobody was rushing to try that idea before this specific project, and why it wasn't an obvious slam dunk even once someone proposed it. Restoring degraded pasture land back into functioning forest is, under normal circumstances, slow and expensive. Once tropical dry forest has been cleared and grazed by cattle for years, the soil it's left behind is often compacted, nutrient-poor, and dominated by aggressive pasture grasses that actively outcompete tree seedlings for light, water, and space. Standard restoration approaches, planting nursery-grown seedlings by hand, one at a time, across large areas, then protecting and maintaining them for years while they establish, takes enormous amounts of labor, time, and money, spread out over decades before a meaningfully mature forest re-emerges. At the scale of the tens of thousands of hectares involved in a project like the Área de Conservación Guanacaste, that kind of hand-planted, seedling-by-seedling restoration simply isn't something you can do everywhere, all at once, even with real institutional will behind it. Every step of that conventional process costs something. Seedlings have to be grown in a nursery first, which means staff, water, time, and space, before a single one ever goes in the ground. Planting them across degraded pasture means clearing competing grass by hand or with machinery, digging individual holes, and getting each seedling into the soil correctly. And planting is only the beginning. Young tree seedlings on former pasture are vulnerable to being outcompeted, trampled, or simply failing to establish, which means follow-up maintenance, replanting failed spots, and monitoring, often for years, before a planted area can be left to grow on its own. Multiply that per hectare cost and labor requirement across the scale of a conservation area measured in tens of thousands of hectares, and it becomes obvious why large stretches of degraded land inside even a well-funded, well-organized conservation project can sit untouched for years, simply waiting for the resources to reach them. Meanwhile, on the industry side, the waste problem wasn't going away either. A citrus processor generating tens of thousands of tons of peel a year doesn't have many appealing options. Landfilling it is expensive and doesn't do anything useful with the material. Composting at that scale requires infrastructure most operations don't have. And selling it into pectin or limonene extraction only absorbs a fraction of total output, leaving the rest as a persistent cost with no natural buyer. The obvious in hindsight idea, physically truck the waste from one problem directly onto the site of the other problem, ran into a wall that had nothing to do with soil chemistry or forest ecology at all. It ran into legal and reputational risk. A national park is not an ordinary piece of land. Dumping 12,000 tons of industrial food byproduct inside a legally protected conservation area, even with good intentions and a formal agreement in place, is the kind of action that looks, on its face, exactly like what conservation law exists to prevent: a company using protected land as a dumping ground. Regardless of what the actual ecological outcome might eventually be, The optics of juice company trucks industrial waste into national park were always going to be a target for scrutiny, criticism, or legal challenge. And that risk existed before a single truckload had even been delivered. This is, in a sense, the central tension running through the entire first half of this story. The same feature that made the idea potentially powerful, using an industrial-scale waste stream instead of a small, manageable, obviously safe quantity of compost, is exactly what made it look alarming to anyone encountering it without the ecological context. A small pile of composted organic matter spread on degraded land wouldn't have raised an eyebrow. 12,000 tons, delivered by 1,000 trucks, from a private company, onto land inside a national park, reads completely differently on paper, even if the underlying material and the underlying science are the same. There was also a purely practical uncertainty sitting underneath all of it. Nobody actually knew, going in, what would happen. Would that much organic material, dumped all at once in a thick layer, smother the soil and kill off what little was still growing there, instead of helping it? Would it simply rot, release its nutrients too fast to matter, and wash away before any lasting benefit took hold? Would invasive weeds and pasture grasses just take advantage of the extra nutrients and grow back even more aggressively than before, choking out the very tree regeneration the project was hoping to encourage? There was no existing precedent at this scale to point to. It was, honestly, a gamble. A plausible one, grounded in basic soil science, but a gamble nonetheless, on land inside a legally protected area, using an industrial company's waste stream as the input. And underneath even that ecological uncertainty was a simpler, more institutional wall, getting anyone with the legal authority to say yes to the idea in the first place. A national park boundary exists precisely to prevent exactly the kind of industrial activity this proposal involved. Even with a legitimate conservation goal behind it, convincing a protected area authority to allow a private company to truck in 12,000 tons of processed food byproduct required real trust in the specific ecologists making the case. Trust built, in this instance, on Daniel Jansen and Winnie Hallwachs's long track record in exactly this landscape, not on the idea being self-evidently safe to anyone encountering it cold. The idea that got past all of that came from two people who had already spent years thinking about this exact landscape in a very specific way. Daniel Jansen and Winnie Hallwachs, a husband and wife team of tropical ecologists who had devoted a large share of their careers to the restoration and conservation of Costa Rica's dry forest. Jansen's long-term research and advocacy in the region is what directly led to the creation of the Área de Conservación Guanacaste in the first place. He wasn't a visiting scientist proposing a one-off experiment on land he had no history with. This was land and an ecosystem he had already spent decades trying to bring back. In 1997, Jansen and Hallwachs approached Del Oro, a Costa Rican orange juice manufacturer, with a specific proposal. Del Oro owned forested land bordering the conservation area. If the company agreed to donate a portion of that land to ACG, permanently expanding the protected area, Del Oro would, in exchange, be allowed to dump its orange peel and pulp waste, free of the disposal costs it would otherwise be paying, onto a specific stretch of degraded pasture land already inside the park boundary. The company got a cheaper, legal outlet for a waste stream it was already generating and already needed to get rid of. The conservation area got both a direct land donation and, if the ecological hypothesis held up, a low-cost way to accelerate the return of forest across a chunk of dead pasture that would otherwise sit unproductive for decades under conventional restoration timelines. Notice what made this specific proposal different from simply asking permission to dump waste. Jansen and Hallwachs weren't offering Del Oro nothing in return for access to the land. They structured the arrangement so the conservation area gained something concrete and permanent, regardless of how the ecological experiment turned out. Even in the worst-case scenario, where the orange peel did nothing useful for the degraded pasture at all, ACG would still have gained a real donation of forested land along its border. That structure mattered. It meant the deal wasn't a one-sided bet on an unproven idea. It was a trade with a guaranteed baseline benefit, with the ecological upside as a bonus if the hypothesis panned out. Del Oro agreed. In 1998, the company began delivering the waste, roughly 1,000 truckloads, adding up to more than 12,000 metric tons of peel and pulp onto the designated 3-hectare site. Heavy machinery spread the material across the degraded pasture in a layer roughly 10 to 50 centimeters thick, thicker in some spots than others, depending on how the trucks unloaded and how the bulldozers pushed the piles around. Picture that logistics operation for a moment. 1,000 separate truckloads is not a single dramatic dumping event. It's a sustained, repeated delivery operation, truck after truck arriving over an extended stretch of time, each one adding its share to a growing, spreading mass of citrus waste across the same 3 hectares. Bulldozer operators had to keep pushing and leveling the material as more arrived, managing a mountain of wet, sugary, quickly fermenting organic matter under the tropical sun. Not exactly a pleasant job, and one that required real coordination between the trucking schedule out of Del Oro's juicing plant and the spreading work happening on site. What happened next, in the short term, looked encouraging. Within about 18 months, the entire mass of orange waste had fully biodegraded into the ground. It didn't just sit there rotting indefinitely. It broke down and integrated into the soil relatively quickly. And even in that short window, people involved with the site were already noting visible changes. Soil that had been compacted and unproductive was showing improved productivity, and native plants were beginning to appear and compete with, rather than simply lose to, the pasture grasses that had dominated the site for years. It looked, on the early evidence, like the basic hypothesis was correct. The specific thing this degraded land needed more than anything else was a massive, one-time infusion of organic material and nutrients. Exactly the kind of thing an industrial-scale citrus operation happened to be sitting on tens of thousands of tons of every single year. There's a basic soil science logic behind why this worked as quickly as it did, even in that first 18-month window. Degraded pasture soil is typically starved of exactly the kind of organic matter that healthy forest soil is built on. The slowly decomposing layer of plant material that feeds soil microorganisms, retains moisture, and gradually releases nutrients back into the ground. A thick layer of citrus waste is, in effect, an enormous, concentrated dose of precisely that missing ingredient, delivered all at once, instead of accumulating naturally over years or decades, the way leaf litter would in an already forested area. It's a shortcut, essentially, compressing a process that would ordinarily take a long time into a single, intense pulse of decomposition and nutrient release. But looked encouraging after 18 months and actually worked are two very different claims. And before anyone could find out which one was true, the project ran straight into the wall that had always been sitting there waiting for it. The skepticism that ended this project didn't come from ecologists questioning the soil science. It came from a courtroom. About a year after the 1997 agreement was signed, while the 12,000 tons of orange waste were already on the ground and biodegrading, a rival Costa Rican juice company, Tico Fruit, filed a lawsuit. Their argument was straightforward and, on its face, not unreasonable. Del Oro had, in Tico Fruit's framing, defiled a national park. Regardless of the ecological intent behind the arrangement, or the direct land donation ACG had received in exchange, Tico Fruit's position was that industrial waste disposal simply had no legitimate place inside a legally protected conservation area, full stop. That the precedent of allowing any company to dump any byproduct on protected land, even with good intentions, was itself the problem, independent of whether this particular byproduct happened to be beneficial. Environmental organizations pushed back on that framing. The Rainforest Alliance testified that the experiment was ecologically sound, that what was actually happening on the ground was closer to accelerated restoration than to pollution, and that treating it as equivalent to illegal dumping missed the actual outcome taking shape at the site. That's a genuinely difficult line to draw in the abstract, well before any of the 16-year data existed. At what point does spreading organic waste on degraded land stop being restoration and start being pollution? Volume, thickness, and material type all plausibly matter, and reasonable environmental scientists could, and did, land on different sides of that specific question in this specific case. That testimony didn't change the outcome. Costa Rica's Supreme Court sided with Tico Fruit, ruled that the arrangement between Del Oro and the conservation area had to be terminated, and the project was shut down. roughly a year after it had started, and only about 18 months after the last of the waste had even finished breaking down into the soil. There's a real, uncomfortable question sitting inside that ruling that's worth taking seriously rather than glossing over. Was the court simply wrong, or was it making a defensible call based on the information available at the time? Nobody in that courtroom had 16 years of forest growth data to point to. Nobody could prove, in 1998, that this specific dumping event would eventually produce dramatically more biomass and tree diversity than an untouched control plot right next door. All anyone had at that point was a company that had brought 1,000 truckloads of industrial food waste into a national park, a rival competitor calling it exactly what it looked like on paper, and a legal system that, reasonably, erred on the side of protecting the park's legal status rather than betting on an unproven ecological outcome. The skepticism wasn't unfounded. It was, in a sense, the correct call given what was actually knowable at the time, even though it turned out, years later, to have shut down something that was quietly working. Consider it from Tico Fruit's position for a moment, setting aside whatever competitive motivation may or may not have factored into their decision to sue. A precedent where any company can strike a private deal to dump industrial byproduct inside a legally protected national park, simply by getting the right ecologists to vouch for it, is a genuinely risky precedent to leave standing, regardless of whether this particular instance happened to turn out well. Today, with the 2017 results in hand, it's easy to look back and treat the lawsuit as the villain of the story. At the time, with only 18 months of early, informal observation to go on and no long-term data of any kind, treating an unproven industrial dumping arrangement with suspicion was not an unreasonable legal or environmental position to take. And then, the project didn't just pause. It disappeared from view entirely. With the legal arrangement terminated, there was no more waste being delivered, no more active monitoring, no funding attached to checking on the site, and no obvious reason for anyone to go back and look. The 3-hectare plot sat inside the conservation area, technically part of the park, physically indistinguishable on any map from the surrounding land, for roughly the next 15 to 16 years. Nobody was actively skeptical about it anymore, because almost nobody was thinking about it at all. It had simply become a footnote, a shut-down experiment from the late 1990s that, as far as most people involved were concerned, had never gotten the chance to prove anything either way. That length of time is worth sitting with. 15 to 16 years is long enough for a person to go from being a graduate student to a tenured researcher, long enough for an entire academic career phase to unfold elsewhere, long enough for institutional memory of a specific shut-down side project to fade out of a conservation area's day-to-day priorities entirely. Nobody made an active decision to abandon the site or to stop caring about the result. It simply fell out of anyone's immediate attention, the way a closed case file sits in a drawer. Not lost exactly, just no longer anyone's job to think about, until a conversation happened to bring it back up. So here is the entire sequence, start to finish. The deal, the delivery, the shutdown, the forgotten years, and the survey that finally measured what actually happened. Step 0. Before any of the numbered steps, the broader restoration context. All of this took place inside a conservation area that Daniel Jansen and Winnie Hallwax had already been working to rebuild for years before Del Oro ever entered the picture. The orange peel plot was never meant to be the whole restoration strategy for ACG, just one experimental piece of a much larger, longer-running effort to bring dry forest back across the conservation area's full footprint. Step 1. The degraded starting point. Before any of this began, the target site was ordinary cattle pasture inside the boundary of the Área de Conservación Guanacaste, cleared of its original tropical dry forest at some point in the 20th century, grazed, compacted, and dominated by pasture grasses. Exactly the kind of low-productivity, slow-to-recover land that made up a large share of the conservation area's territory before its long-term restoration work began. Land like this represented exactly the kind of stubborn, in-between landscape that conservation areas often struggle with most. Not actively being destroyed further, but not recovering on its own either. Simply occupying space within the park boundary while contributing very little to the ecosystem the park existed to protect. Step 2. The proposal. In 1997, Daniel Jansen and Winnie Hallwax approached Del Oro directly with the specific exchange: a permanent land donation from Del Oro to ACG in return for free, legal, on-site disposal of the company's orange peel and pulp waste onto a defined stretch of that degraded pasture. This wasn't a cold pitch to a stranger. It was two ecologists with decades of credibility in exactly this landscape, proposing a specific, bounded trial on a specific, bounded plot, not an open-ended arrangement to dump waste anywhere in the park indefinitely. Step 3. The agreement. Del Oro accepted the terms. The company would donate part of its own forested land bordering the conservation area, and in exchange would be permitted to deliver its waste to the designated 3-hectare site rather than paying for standard disposal. From the company's side, this was a straightforwardly rational business decision, a legal, sanctioned way to eliminate a recurring disposal cost in exchange for handing over land the company wasn't using for juice production anyway. Step 4. The delivery. Beginning in 1998, trucks began hauling orange peel and pulp waste from Del Oro's juicing operation to the site. Roughly 1,000 truckloads over the course of the operation, totaling more than 12,000 metric tons of material. For scale, that's an average of roughly 12 tons of peel and pulp per truckload, arriving steadily rather than all at once, over whatever span of weeks or months it took to complete 1,000 separate deliveries from the juicing plant to the park boundary. Step 5. The spreading. Heavy machinery, bulldozers, and similar equipment pushed and leveled the delivered waste across the 3-hectare target area, building up a layer that ranged from roughly 10 centimeters thick in some spots to as much as half a meter thick in others, depending on how material accumulated as truck after truck unloaded. Getting that spread even enough to cover the full target area, rather than piling up unevenly around the unloading points, required real coordination between the incoming truck schedule and the equipment operators working the ground. Not a single dramatic dump, but a managed, ongoing construction-style operation. Step 6. The biodegradation. Over the following 18 months, the entire mass of orange waste broke down into the ground. This wasn't a slow, indefinite decomposition process stretching out for years. Within a year and a half, visually and functionally, the peel was gone, integrated into the soil rather than sitting on top of it. A tropical climate helped that timeline considerably. Consistent warmth and humidity accelerate microbial decomposition far faster than a temperate climate would, which is part of why a waste layer half a meter thick in places could fully break down in a year and a half rather than taking many years longer, as the same volume of organic material might in a cooler region. Step 7. The early signs. During and shortly after that 18-month breakdown period, observers noted the first indications that something real was happening. Improved soil productivity and native plant species beginning to take hold and compete against the pasture grasses that had previously dominated the site unchallenged. These were informal, on-the-ground observations rather than a rigorous survey. Nobody was running a formal measurement protocol at this stage, but they were consistent enough to suggest the underlying hypothesis had real merit, right before the legal challenge arrived and cut the observation period short. Step 8. The lawsuit. Roughly a year after the 1997 agreement was signed, Ticofruit filed suit against the arrangement, arguing Del Oro had defiled a national park by using it as a waste disposal site. The timing meant the lawsuit landed right in the middle of the biodegradation window. The orange waste was still actively breaking down into the soil. The very earliest positive signs were only just becoming visible, and none of the eventual 16-year data existed yet to weigh against the legal argument being made in court. Step 9. The ruling. Costa Rica's Supreme Court ruled in Ticofruit's favor. The Rainforest Alliance's testimony that the project was ecologically sound did not change the outcome. The court ordered the Del Oro ACG arrangement terminated. It's a genuinely notable detail that even direct, credible testimony from a recognized environmental organization wasn't enough to change the ruling. The legal question the court was answering was about the legitimacy of the arrangement itself, not a scientific referendum on whether the ecological outcome so far looked promising. Step 10. The shutdown. With the ruling in place, no further orange waste was delivered to the site. The formal arrangement ended, and active involvement with the plot stopped almost entirely. Whatever additional waste Del Oro had been planning to deliver over a longer timeline simply went back to being disposed of through the company's ordinary, standard, presumably more expensive channels. The specific arrangement that had made this one plot's transformation possible was gone, with no similar deal replacing it anywhere else in the conservation area. Step 11. The Forgotten Years. For roughly the next 15 to 16 years, the 3-hectare site sat inside the conservation area with no dedicated monitoring, no ongoing project attached to it, and essentially no attention from anyone outside of the small group of people who had been involved in the original 1997 to 1998 agreement. Rain fell, seasons cycled through wet and dry, and whatever regeneration was or wasn't happening on that plot proceeded entirely unobserved and unrecorded, with nobody keeping so much as an informal note on its condition year to year. Between Step 11 and Step 12, nothing happened. That gap, 15 to 16 years with no recorded events at all connected to this specific plot, is itself part of the sequence worth naming explicitly, because it's the single longest stretch in this entire story, and the one during which the actual outcome was quietly taking shape with zero human involvement of any kind. Step 12. The Rediscovery. In 2013, Timothy Troyer, a Princeton researcher, was discussing potential research directions with Daniel Jansen when the old orange peel site came up in conversation. On a separate, otherwise unrelated research trip to Costa Rica, Troyer decided to make a detour and go see what, if anything, remained of it. It's worth pausing on how contingent this moment actually was. Troyer wasn't dispatched specifically to check on the site, wasn't funded to investigate it, and had no guarantee it would be worth the detour at all. It was, essentially, professional curiosity, the kind of might as well take a look while I'm nearby decision that, in this case, happened to reopen a scientifically significant question that had been sitting untouched for a decade and a half. Step 13. The First Look. What Troyer found at the site did not match the 15 years forgotten, still mostly pasture expectation. Instead of scrubby grassland, he found land that looked, by eye, like genuine forest, visibly taller, denser, and greener than what anyone would have predicted for an unmonitored plot, left alone for a decade and a half. That gap between expectation and reality is what turned a casual detour into the starting point of a formal research project, a first-hand visual impression striking enough to be worth returning to properly, with instruments and a methodology, rather than just a passing anecdote to mention to colleagues back at the university. Step 14. Designing the follow-up survey. That visual impression was the trigger for a proper scientific comparison. Troyer, working with Jansen and Halvox, set out to measure the site systematically, rather than rely on a first impression, and, critically, to compare it directly against a genuine control, an adjacent area of similar former pasture land, on the other side of an access road, that had never received any orange waste at all, giving them a like-for-like baseline for what, no intervention, same amount of time, actually looked like on the same landscape. Choosing that specific control plot mattered enormously for the credibility of whatever the researchers found. Without a genuinely comparable untreated area sitting right next door, exposed to the same rainfall, same soil type, same regional tree seed sources, and same 15 years of elapsed time, there would be no way to confidently attribute any difference specifically to the orange peel, rather than to some other factor entirely. Step 15. The measuring tape method. The survey itself used a deliberately low-tech, transparent methodology. Researchers stretched measuring tape out in 100-meter lines, laid 3 separate lines in parallel, 25 meters apart, through the orange peel-treated plot, and then repeated the exact same measuring process, 3 more lines, through the untreated control plot on the other side of the road. 600 meters of tape in total, walked and measured by hand, across 2 plots that from a distance would have looked like an ordinary afternoon of fieldwork, rather than the moment a 15-year-old scientific question was finally about to get answered. Step 16. The tree census. Along every one of those measuring tape lines, Researchers measured and identified every single tree within 3 meters of the tape. Its species were identifiable, and its size, building a direct, comparable data set of what kind of forest and how much of it had actually grown in each of the 2 areas over the same span of time. It's genuinely low-tech fieldwork. No drones, no satellite imagery, no expensive remote sensing equipment. A measuring tape, a notebook, and researchers walking a fixed transect, identifying and measuring trees by hand. The same basic method field ecologists have used for generations, applied here to answer a question that had been sitting unanswered for 15 years. Step 17. The comparison. With both data sets complete, the difference between the treated site and the untreated control wasn't subtle. The orange peel-treated plot showed a 176% increase in above-ground woody biomass compared to the control, meaning, in simple terms, roughly 2 3/4 times as much actual wood as tree trunk and branch mass growing on the treated land as on the untouched comparison plot over the same period. The treated plot also had roughly 3 times the number and diversity of tree species found along the same length of measuring tape, along with visibly richer soil and greater forest canopy closure, meaning more of the sky above the plot was blocked by an actual tree canopy rather than open pasture sky. Every one of those differences pointed the same direction, which is part of what made the result convincing rather than ambiguous. This wasn't one positive metric buried among several inconclusive ones. It was biomass, species diversity, soil quality, and canopy closure, all independently showing the same treated versus control gap. Step 18. Publication. The findings were published as Low-Cost Agricultural Waste Accelerates Tropical Forest Regeneration in the journal Reforestation Ecology on August 22, 2017, nearly 20 years after the original 1997 agreement, and roughly 16 years after the last truckload of orange waste had been delivered to the site. The title itself is a quiet piece of vindication, a peer-reviewed journal publishing a paper whose core finding directly undercuts the premise that shut the project down in the first place, that this specific use of agricultural waste on this specific patch of protected land had, in fact, accelerated exactly the kind of regeneration ACG existed to encourage. That's the full sequence. A degraded pasture, a proposal built around trading land for waste disposal, 1,000 truckloads, and 12,000 tons of peel spread across 3 hectares, 18 months of biodegradation, a lawsuit that shut it all down within about a year, 15 to 16 years of total silence, a chance conversation that sent one researcher back to look, and a simple measuring tape survey that turned a forgotten legal footnote into one of the most cited examples of low-cost tropical forest restoration in recent conservation science. What's striking, looking back at the full sequence end-to-end, is how little of it was actually complicated. There's no proprietary technology anywhere in this story, no genetically engineered seed, no expensive infrastructure build-out. A truck fleet, a stretch of degraded land, a chemical process that happens naturally whenever organic matter breaks down in soil, and, 16 years later, a measuring tape. The complexity in this story isn't technical. It's entirely in the legal, institutional, and human chain of events. The specific people who had to trust each other, the specific lawsuit that had to happen, the specific decade and a half that had to pass unnoticed, and the specific conversation that had to occur for anyone to ever find out what the simple part of the process had actually produced. Line up the actual measured outcomes, and the scale of what a single, relatively short-lived, legally terminated experiment produced is genuinely striking. On 3 hectares of land, a modest area, easily walkable in a few minutes, 16 years after the last of 12,000 tons of orange peel was delivered and left to break down, researchers measured a 176% increase in above-ground woody biomass compared to an identical, untreated plot right next door. Roughly 3 times the number and diversity of tree species had established themselves on the treated land. The soil was measurably richer. The canopy overhead had closed in far more completely, turning what should have still resembled degraded pasture into something that, by eye, reads as functioning young forest. Put the biomass number in plain terms. 176% more above-ground wood than the control plot means the treated land wasn't just slightly ahead of its untreated neighbor after the same 15+ years, it had very nearly tripled it. Two patches of land, same starting condition, same climate, same span of time, same complete absence of active management after the initial event, and one of them ended up carrying roughly 2 3/4 times as much actual tree biomass as the other. That's not the kind of gap you'd expect from ordinary variation in how a landscape happens to regenerate. That's the signature of a single, specific intervention still driving a measurable outcome a decade and a half after it happened. And all of that came from an input that cost the conservation area essentially nothing. In fact, the arrangement went the other direction financially. Del Oro was the one saving money, avoiding standard waste disposal costs by delivering its peel to the site instead, while ACG received both a direct land donation and, it turned out, a dramatic acceleration in forest recovery on degraded ground that would otherwise have taken vastly longer and cost vastly more in active planting and maintenance to reach anything close to the same state. That's the detail behind Timothy Troyer's description of the result as cost-negative carbon sequestration, a case where storing carbon in newly grown forest biomass wasn't just cheap, it was effectively funded by a company that was already looking for somewhere to put its waste regardless. Compare that funding structure to almost any other tropical reforestation project you could name. Most rely on grants, donations, carbon credit financing, or direct government spending. Money that has to be actively raised, allocated, and justified year after year, specifically for the purpose of growing trees. This project never had a conservation budget line at all. Every dollar of value it generated came from a private company's ordinary waste management decision, made for entirely commercial reasons, that happened to double as one of the most effective low-cost restoration interventions ever documented at this scale. Nobody had to convince a donor that regrowing 3 hectares of dry forest was worth funding. The funding, in effect, already existed, sitting inside Del Oro's disposal budget, waiting to be redirected. Zoom back out to the scale this all sits inside, and the payoff looks even more significant. The Área de Conservación Guanacaste, the broader conservation area this 3-hectare plot belongs to, has grown from an initial roughly 10,000 hectares of degraded land into a restored, functioning ecosystem, now covering something on the order of 169,000 hectares, spanning marine, dry forest, cloud forest, and rainforest zones, recognized internationally as one of the best working examples of conservation through active biodevelopment anywhere in the world. The largest forest restoration project on the planet by some measures, and a UNESCO World Heritage Site that has served as a working model for how the rest of Costa Rica's national park system operates. The orange peel experiment is a small, specific data point inside that much larger, decades-long restoration effort. But it's a data point that suggests something with real implications well beyond this one plot. That in the right circumstances, industrial waste that would otherwise cost money to dispose of can, instead, be turned directly into one of the cheapest, fastest tools available for restoring exactly the kind of degraded tropical land that standard reforestation struggles to tackle at scale. Set the 3-hectare plot next to that 169,000-hectare total, and the proportion looks almost comically small. This single experiment covers a sliver small enough to be a rounding error against the full conservation area. But that's exactly what makes the result worth taking seriously, rather than dismissing as a fluke of one lucky plot. The mechanism behind the outcome: organic waste breaking down and returning nutrients and structure to degraded soil, isn't something specific to this 3-hectare rectangle. It's basic soil ecology. The same processes that would apply anywhere degraded tropical pasture meets a large enough pulse of organic material. The plot is small. The idea it demonstrates is not. There's something worth sitting with in the fact that this specific result almost didn't get discovered at all. The experiment wasn't monitored, wasn't maintained, wasn't part of any ongoing research program during the 15+ years it sat forgotten. It survived and thrived entirely on its own, with zero further investment or attention from anyone. And the only reason anyone knows what actually happened there is that one researcher, in an unrelated conversation, happened to remember it existed and took a short detour to go check. If that conversation hadn't happened, or if Troyer hadn't made the stop, this would likely still be an unexamined legal footnote today. A shut-down 1990s experiment, filed away as evidence that dumping industrial waste in national parks doesn't work, when the actual, unmeasured reality sitting quietly on the ground said the exact opposite. It's worth imagining for a moment the version of this story where that detour never happens. Somewhere in a legal archive, the Tico fruit ruling still exists as precedent. A court found in favor of the argument that a company had defiled a national park. The arrangement was terminated, and the file closed. Anyone researching the history of industrial waste disposal in protected areas would find exactly that outcome, and nothing more. A cautionary tale, correctly decided as far as the available evidence went, that happened to be sitting 3 hectares away from a forest, quietly proving the opposite conclusion. The gap between what actually happened ecologically and what the historical record would have shown, absent one chance visit, is the whole story in miniature. That's a genuinely useful lesson that goes beyond this one story. The gap between "this looked risky and got shut down" and "this actually worked" can sit completely unexamined for years, even decades, simply because nobody thought to go back and check. The court that ruled against Del Oro and ACG in 1998 wasn't wrong to be cautious. Dumping industrial waste inside a national park is exactly the kind of action that deserves scrutiny. And nobody involved had the 16 years of data that would eventually vindicate the idea. But caution and a final verdict aren't the same thing. And this particular case is a reminder that "we don't know yet" sometimes gets quietly reclassified as "we know it failed," simply because nobody circled back. Widen the lens one more time, and the story becomes about something bigger than one plot of land in northwestern Costa Rica. Tropical dry forest is disappearing faster, proportionally, than almost any other major tropical ecosystem on the planet. More than 71 million hectares gone in 20 years, only around a third of the original global extent left standing, and less than a third of what remains under any kind of formal protection. Standard restoration, seedling by seedling, hectare by hectare, is slow and expensive at exactly the moment this ecosystem doesn't have time to wait. Meanwhile, the global citrus industry alone generates on the order of 24 million tons of peel, pulp, and seed waste every single year, a number that dwarfs the 12,000 tons used in this one experiment by a factor of roughly 2,000. Nobody is claiming orange peel alone can reforest the tropics, but the core idea this experiment tested, that a waste stream one industry is already paying to get rid of, might be exactly what a degraded ecosystem somewhere else desperately needs, is not a one-time coincidence specific to oranges and Costa Rica. It's a pattern worth looking for anywhere a disposal cost on one side of an industry happens to line up with a restoration cost on the other. That mismatch between the scale of the waste available and the scale of what actually got used here is itself worth dwelling on. 12,000 tons sounds enormous until it's set against 24 million tons of citrus waste generated globally every single year. At that ratio, the entire Costa Rican experiment used something on the order of 1/20,000th of a single year's global citrus byproduct. If a result this dramatic came from a rounding error's worth of the available raw material, the obvious follow-up question isn't whether the idea works. The 2017 data already answered that. The obvious follow-up question is why an approach this cheap, this well-documented, and this clearly effective hasn't been repeated more often since, and whether the legal and reputational caution that shut this specific project down in 1998 is still, decades later, quietly preventing other degraded landscapes from getting the same treatment. There's also a quieter point buried in Timothy Troyer's cost-negative carbon sequestration framing that's worth pulling out explicitly. Most conversations about storing carbon and growing forests treat it as an expense. Land has to be bought or protected. Seedlings have to be grown and planted. Years of maintenance have to be funded, all in service of a climate benefit that accrues slowly and doesn't generate direct revenue. This experiment inverted that entirely. The waste-generating side of the equation was already paying money to dispose of its byproduct somewhere. Redirecting that existing expense onto degraded conservation land didn't add a new cost to the restoration side of the ledger. It replaced an expense the industry was already paying with one that happened to also regrow a forest. That's a genuinely rare structure in conservation economics, and it's a large part of why this 15 years forgotten experiment keeps getting cited well beyond the field of tropical ecology specifically. It also raises a fair, unresolved question this episode should be honest about rather than paper over. Nobody has yet demonstrated, in a rigorously published follow-up, that this exact approach scales cleanly beyond a 3-hectare pilot. 1,000 truckloads onto 3 hectares is one thing. Whether an equivalent, proportionally scaled version, say 10 times the waste onto 30 hectares, or matching an entire year of one company's total peel output to an equivalently sized stretch of degraded land, would produce the same dramatic biomass and diversity gains, or would run into new problems around excessive nutrient loading, uneven application, or overwhelmed soil microbial systems, is genuinely unknown. The 2017 study is strong evidence that the underlying idea works at the scale it was tested. It is not, on its own, proof that simply repeating the recipe at 10 or 100 times the size would produce a proportionally larger benefit. There's one more thread worth pulling before closing this out. What this story implies about how much other forgotten, dismissed, or shut down environmental experimentation might be sitting out there right now, quietly succeeding or failing with nobody checking either way. Conservation science, like most fields, moves on. Funding cycles end, researchers change institutions, legal setbacks discourage revisiting old ideas, and unless something forces a second look, a shutdown project simply stays shut down in the historical record, regardless of what actually happened on the ground afterward. This specific case got its second look because of a personal conversation and a convenient detour. There's no reason to assume every comparably promising, comparably abandoned idea gets that same lucky break. Think about how many other pilot projects, in any field, get shut down early for defensible legal, financial, or political reasons, long before anyone has enough data to know whether the underlying idea was actually sound. Most of those projects never get revisited. The people involved move on to other work, the institutional memory fades, and the file simply closes on whatever conclusion was reachable at the time of shutdown, correct or not. This is the rare case where, purely by chance, someone went back years later and actually checked. It worked out. It's worth wondering how many others like it never get that chance. If you've made it this far, you now know the full, slightly absurd, entirely true story behind one of the strangest reforestation success stories in modern conservation science. A lawsuit that killed a project in under 2 years, 15 forgotten years of total silence, and a measuring tape that eventually proved the losing side of that lawsuit had accidentally been right all along. If stories like this, places and projects everyone had already written off, quietly succeeding while nobody was watching, are what keep you watching, subscribe, because the next one is already out there, sitting forgotten somewhere, waiting for someone to go back and check.